Good morning, Strand. In this video lesson, we're going to talk about the areas under the normal curve that corresponds to a certain probabilities. Also, we're going to talk about on how to convert z-scores to raw scores and raw scores to z-scores. In the last video lesson, I've taught you on how to get the area of a specific z-score. So to illustrate the normal curve, for example, if we have a z-score of 1, just draw a vertical line and then shade it from the mean up to the z-score 1. And to get the area of that shaded portion in the normal curve, just simply get your z-table and then 1.00 is in a 3-digit form. So just determine the first 2 digit of 1.00, and the first 2 digit is 1.0. Then locate it on the left side of your z table and determine the last digit, that is 0.00, and locate it above your z table. Then get the intersection of that. Therefore, that is our area from the mean up to the specific z-score. So in this video lesson, we're going to determine the probability of a z-score if it is above or below, between, and above a specific value. To understand it further, let's look at this example. So this normal curve wants us to identify the area of the z-score from the mean, which is 1. So the area between, so we're getting this area, the area between the mean from the z-score 1. So we're getting the area between z equals 0 and z equals 1. And that is equal to 0.3413. In percent, that is equivalent to 34.13%. Just simply move 2 decimal places to the right, 1, 2. So after moving 2 decimal places to the right, so it becomes 34.13, and then you affix percent sign. So therefore, so how did I get 0.3413? Just look at your z table, locate 1.0 to the left side of your z table, and locate 0.00 on the top of your z table, then get the intersection. And you will see 0.3413. So this means that the probability of the z-score having a value between 0 and 1 is 0.3413 or 34.13%. In determining the probabilities using a standard normal curve, you're also finding the area of the shaded region using the bell curve using z table. So we have 3 cases. The first case is that if you see the word less than, at most, to the left, below, not more than, therefore, you will shade the areas from the given z-score to the left. And the probability notation is always z is less than the specific value given. So let's have an example. So the first example is below -1. So we saw the word below, and therefore that is under case 1. So therefore the probability notation is it has, or it should be, less than, the symbol less than. And also the areas below a z-score, this represents the probability of a z-score less than a specific value. So how do we draw the normal curve using this condition below z equals -1? So first thing you need to do is to identify, draw a normal curve, of course, and then you locate z-score -1. This is z-score -1. Then since it is under case 1 because of the word below, you will simply shade the left part of -1. So therefore, the shaded part is this one. And also, if you're struggling to memorize the words, the keywords under case 1, just simply imagine what are the numbers below z equals -1. Is it 0, 1, 2, 3? Is 0, 1, 2, 3 below -1? Or is it -2, -3? Is -2 or -3 below -1? If your answer is yes, therefore you are correct. If -2 and -3 is below -1, therefore you will shade to the left. If you're having difficulty on memorizing those keywords, less than, at most, to the left, below, or the word not more than. And of course, as I've said a while ago, the probability notation is less than. Therefore, the probability notation in example number 1 is P, open parenthesis, Z less than -1. After that, after getting the probability notation and drawing the normal curve, we are now ready to find the area below Z equals -1. So to find the area, the first thing you need to do is to get the area of -1 on the Z table. So the area of -1 on the Z table is 0.3413. So it doesn't matter if it's negative or positive, right? Just disregard the negative sign to get the area. So we have 0.5 minus 3413. Therefore, the area of this shaded normal curve is 0.1587 or 15.87%. Why did I subtract 0.5 by the area of -1? Isn't it by remembering the probability or the properties of a normal distribution, we know that the area of the normal curve is equivalent to 1, or that is equal to 100%. And knowing that the area is symmetrical about its mean, therefore, this face and this face is equal or congruent. Therefore, if the area of the whole normal curve is 1 or 100%, therefore, half of that is 0.5 or 50%. This is 50% and this is 50%. Now, to get the area of this one, first thing you need to do is to identify the area of the unshaded portion of the left part of the normal curve. So we know that that is 0.3413. So if this unshaded area from the mean up to -1 is 0.3413, how will you get the area of this one? By simply subtracting 0.5, because we know that the area of the half of the normal curve is 0.5. Just simply subtract 0.5 by 0.3413. Therefore, the answer is 0.1587 or 15.87%. So moving on to the next. How about this? To the left of z equals +1. So we have the keyword to the left. Therefore, our probability notation is less than. Z is less than 1. But first, let's illustrate the normal curve. This is the normal curve of to the left of z equals 1. Since it is to the left, therefore, we will shade the left part of the normal curve from z equals 1. So if this is z equals 1, then you will shade all parts to the left of positive 1. Can you guess the probability notation of this one? So if your answer is P, open parenthesis, Z is less than 1, therefore you are correct. How about the area? What have you noticed? So half the normal curve is shaded. And we know that from the mean up to 1, the area of that is 0.3413, right? So what will you do to 0.3413, this area, to this area which is shaded? Just simply add 0.5, this area, plus this area which is 0.3413. Therefore, that is 0.8413 or 84.13%. So what's the technique here? So after drawing the normal curve, if you notice that the area or the shaded region does not, or it doesn't pass through the mean, therefore you will subtract. If it passes through the mean, the shaded part, it passes through the mean, therefore you will add. That is the technique there. Whether you add or subtract 0.5 to the given z-score. So just simply look, how will you know what number you will add or subtract to 0.5? Just simply look at the given z-score, which is -1 and +1, and then you get the area of that using the z-table. So the area of -1 and +1 are both 0.3413. Then do not forget to convert decimal, the area, from decimal to percent. Now let us move to case number 2. If case number 1, when you hear the keywords less than, at most, to the left, below, or not more than, you will shade to the left. But this one, in case number 2, wherein the area is above a z-score, this represents that the probability of a z-score is greater than a specific value. So in this case, you will shade to the right if you have or you saw the keywords greater than, more than, above, or at least. And also the probability notation will be greater than. So let's have our first example. What if the z equals 1 is above, or above z equals 1? So of course, the first thing you need to do is to illustrate the normal curve. So illustrating the normal curve is a big help in identifying whether you add or subtract 0.5 from the certain z-score. So to illustrate that, so first locate z equals 1. So here is z equals 1. And then since we have the keyword above, therefore we will shade to the right. It's the opposite of the first one. So, and also, just simply imagine if, what are the numbers above 1? Is it 0, -1, -2, -3, or 2 and 3? What are the numbers above 1? Of course, it's 2 and 3. That's why you will shade 1 to the right. So for the probability notation, of course, as I've said a while ago, that you will use greater than. So therefore, the probability notation is P is open parenthesis Z is greater than the given Z score, which is 1. Now for the area, does it touches or Does it touches the mean? Of course, it does not touch the mean. Therefore, do you add or subtract? Of course, you will subtract. So 0.5 minus the area of 1, by looking at the Z table, you will get 0.3413. Therefore, that is equal to 0.1587, or in percent, that is 15.87%. So example number 2, what about this? At least Z equals -1. So the keywords in case 2 are greater than, more than, above, and at least. So it's under case 2 because of the word at least. And just imagine, by just looking, or when you're struggling or having a difficulty, if it's case 1 or case 2, just imagine what are the numbers at least -1. If, for example, if your mother is asking you to buy a soy sauce at a store, so for example, she said that please buy at least 5 packs of soy sauce. So how many soy sauce will you buy if she said at least 5? So if your answer is 5 or more, therefore you are correct. So you can buy 5, 6, 7, 8, or if you notice the pattern there, you will buy, or it's in ascending order, right? Like it's a number greater than that value. So in this one, what are the numbers greater than -1? Is it 0, 1, 2, 3, or -2, -3? So of course, it's 0, 1, 2, 3. That's why when you draw the normal curve, you will shade to the right. So for the probability notation, of course, it's P open parentheses, Z is greater than -1. So for the area, it touches the mean. Therefore, what will you do? Will you add or subtract 0.5 from the area of -1? Of course, it touches the mean, you will add. Therefore, we have the area 0.8413, or 84.13%. And also take note for the normal curve. So this is the tail. It should not touch the baseline, right? Because it's according to the property, it is asymptotic to the baseline. So when you draw your normal curve, please make sure that it does not touch the baseline. And of course, when it's case 1 and case 2, you will shade up until the tail, or uh, longer than -3 or +3, okay? So, next. So, adding and subtracting 0.5 to a specific area of the z-score is only applicable in case 1 and case 2. But what if we have a given wherein the area is between two z-scores? So, area between two z-scores represents the probability of a z-score between two specific values. So, let's have an example. And also, before I forget, when you see the word or the keyword between or middle, therefore, that is under case 3, which is this one. So if it is under case 3, you see the word between or middle, you will shade between, of course. So, and the probability notation will be Z is greater than A but less than B. where A and B are value of Z. So let's have an example. First one is between Z equals -1 and Z equals 1. So the normal curve of that is this. So first is we locate -1, this is -1, then we locate +1, this is +1. Draw a vertical line and shade the area between. So in case 1, you will shade the area to the left, up to the tail. In case 2, you will shade the area to the right, up to the tail, this one. In case 3, you will shade between the two given z-scores, which is -1 and +1. For the probability notation, it's both greater than and less than. But you will write on the first one, the smaller one to the larger one. Example. Therefore, this probability notation is P, open parenthesis, Z is greater than -1 but less than +1. So, yung mas maliit na value, dito siya banda sa left. And yung mas malaking value, dito siya banda sa right. And to find the area, you will no longer deal with 0.5 because it's under case 3. What you will do is you get the area of the first z-score and the area of the last z-score. So the area of -1 and +1 are both 0.3413. And then you identify on the normal curve if it touches the mean. Does it touch the mean? Yes, of course, it's at the middle. Therefore, what will you do? Will you add or subtract? Of course, you will add. That's the technique there. So therefore, you will add the area of -1, which is 0.3413, and the area of +1, which is 0.3413. Therefore, the total area between -1 and 1 is 0.6826 or 68.26. This is 6. So 68.26%. So I hope you got it, got the technique. But let's have another example. What if it's like this? So it's between z equals 1 and z equals 2. In the first example, it's 1 is negative and 1 is positive. What about if they are both positive? So let's draw the normal curve first. So this is +1. This is +2. Since we have the word between, we will shade the area between 1 and 2. So for the probability notation, of course, the smaller digit is 1 and the larger digit is 2. Therefore, we have the probability notation z is greater than 1 but less than 2. And for the area, of course, we find the area of 1, we find the area of 2. Since it does not touch the mean, therefore, what will you do? Will you add or subtract? Of course, you will subtract. So, you subtract the area of the larger z-score to the area of the smaller z-score. So, that is the area of +2 is 0.4772 and the area of +1 is 0.3413 since it does not touch the mean. Therefore, you will subtract the larger area to the smaller area and that gives us an answer of 0.1359 or 13.59%. So, ma'am, where did you get 0.4772 and 0.3413? Of course, I got the values or the areas of 2 and 1 at the Z table. So, do not forget your Z table. Okay, next example. Okay, between z equals -2 and z equals -3, what if they are both, the z-scores are both negative? Of course, let's first draw. This is -2, and this is -3. So this is the area between -2 and -3. And of course, the question there is this under case 1? Because it's shaded to the left, right? So is it under case 1 or still case 3? Of course, you see or you saw the word between. That's why it's under case 3. And of course, regarding the figure or the shaded portion, it's only up to -3. Remember that still after -3, we have -4. Because up to -3 to +3, the area is only 99.74% if I'm not mistaken. And the areas after -3 and the areas after +3, we still have a z-score there. And we still have the area 0.26%. That's why we still have area over here. Though um it's not seen here, but when you graph or illustrate your normal curve should be asymptotic to the baseline so that you will see the figure properly. So let's move for the probability notation. So which is greater? Is it -2 or -3? Or the question here is, since the first digit we write is the smaller one, which is smaller, -2 or -3? If your answer is -3, you are correct. Remember, when dealing with negative integers, it's the inverse or opposite. The larger the number of that negative, the smaller it gets. So we have the probability notation P, wherein z is greater than -3 but less than -2. For the area, just simply get the area of -2 and the area of -3. After getting the area on the z table, you just subtract the larger area to the smaller area. So we have 0.4987, which is the area of -3. The area of -2 is 0.4772. You subtract them and you will get 0.0215 or 2.15%. So in our previous example, case 1, case 2, and case 3, here are the probability notations. For case 3, we have this probability notation. It denotes that the probability that the z-score is between A and B. While this one, z is greater than A, it denotes that the z-score is greater than A, which is what case? It's case 2. And for this one, z is less than A, the probability that z-score is less than A, that is case 1, wherein A and B are the z-score values. So again, for example, to denote the area or probability between 1 and 2, we use the notation probability where z is greater than 1 but less than 2. So to find the area between 1 and 2, just simply get the area of 1, get the area of 2 from the z table, then you subtract the bigger area, which is the area of 2, to the smaller area, which is the area of 1, to get the area between 1 and 2, which is 0.1359, or in percent, that is equivalent to 13.1859%. So therefore, the probability that the z-score falls between 1 and 2 is 0.1359 or 13.59%. So let us answer the following. Number 1 to 2, less than z equals -1.75. First thing we need to do is to identify or draw the normal curve. So let's locate -1.75. Is it between 0 and -1 or -1, 2. Of course, the answer is -1 and -2. And we cannot place it at the middle. Rather, we can place it at closer to the 2, -2. So, maybe here. So, assuming, no, that this is -1.75 by writing -1.75. And please do not forget to write the area or the z-score -1.75 because how can I know that that is -1.75 and not -1.76? So since we have the keyword less than, therefore we will shade to the left or right. Of course, we will shade to the left. So this is the area that is less than -1.75. So our probability notation is z is less than -1.75. So when you have the word less than, of course, you will use the symbol less than. And for the area, let's locate the area of -1.75. First thing we need to do is to determine the first two digit. The first two digit is 1.7 regardless of the decimal point, right? So 1.7 is over here. Yan. So this z table, the z table presented is, I only cut it, but it's up to 3.09, right? Okay. So that you can see it clearly. That's why I cropped this image. And locate the third digit of 1.75, and that is 0.05. This is 0.05, and you get the intersection. So therefore, the area is what? 0.4599. Now, the question, will you add or subtract 0.5 to the to 0.4599? So the question there is, does it touch the mean? Of course not. That's why you will add or subtract. You will subtract. So for the solution, we have 0.5 minus 0.4599. This is how you show your solution when you're computing manually. But regardless of the affixed 3 zeros here, you can solve this right away when you input it in your calculator. But anyways, therefore, our area is 0.0401, or that's equivalent to 4.01%. So over here, how about this? Less than z equals 1.75. So this time around, it's positive 1.75 and it's between 1 and 2, of course. So assuming that that is 1.75, do not forget to write 1.75 here at the top. Sorry for uh, the way I write because I'm only using mouse. So anyways, let's shade, no? What are the numbers less than 1.75? So is it 1 or 2? What is 1.75 less than 1 or 2? Or what are the numbers rather? What are the numbers less than 1.75? Is it 1 or 2? Of course, it is 1. So therefore, you will shade to the left. And of course, you have the keyword less than. That's why you will shade to the left. So it's better to memorize. so that you will no longer have to imagine if it's left or right. So don't mind the shading, no? I only use mouse here. That's why yun medyo nahihirapan ako. Anyways, so the probability notation is still less than. So we have P where Z is less than 1.75. Therefore, the area of that is still 0.4599 still. So it doesn't matter if it's negative or positive. In the Z table, they have the same area. So, yeah. So, and then, do we subtract or add 0.5 to 0.4599? Of course, it touches the mean, therefore we will add. So for the solution, we will add it. Therefore, we have 0.9599 or 95.99%. Therefore, we can say that probability notation wherein Z um, less than 1.75 is equal to 95.99%. So let's just make the discussion quick. This is just another example anyways. So for here, two examples, we have the word more than. So if it's more than, we will shade to the right. So let's locate 1.9. So that is near positive 2. And we will shade to the right. So you can pause this video lesson and do it first before you play it. Okay. So that is 1.9. And do not forget to write 1.9 over here. I will no longer write it. So let's determine the area on the Z table. First two digit is 1.9 and here is 1.9. And of course, the last digit is 0. That's why we will have 0.00. Therefore, the intersection of 1.9 and 0.00 is 0.4713. Therefore, the area is 0.4713. But first, let's have the probability notation. And since it's more than, therefore, we will use the greater than symbol. So we have Z is greater than the given Z score, which is 1.9 or 1.90. So that the area equivalent to Z score of 1.9 is 0.4713. Therefore, will we add or subtract? Of course, we will subtract because it does not touch the mean. So 0.5 minus the area of 1.9, and that gives us 2.78%. Therefore, we can say that the probability wherein C is greater than 1.9 is 2.78%. For next example, more than Z equals negative 1.9. So negative 1.9 is closer to negative 2. Then we shade it. Of course, it's more than what are the numbers? More than 1.9. So you will shade to the right, up to the tail, of course. And when you're shading, please make sure that it's solid, no? Okay, up to the tail, of course, no? Do not forget the tail. Okay, and then what do you think is the probability notation? If your answer is Z is greater than negative 1.9, you're correct. And the area is still 0.4713. Will you add or subtract? Of course, you will add because it passes through the mean. Therefore, 0.5 plus the area of 1.9. Therefore, our answer is 97.13%. And we can say that the probability wherein Z is greater than negative 1.9 is 97.13%. Next one, since we encountered the words between here, therefore we will no longer add or subtract from 0.5. Rather, we will add or subtract from the given area of the following Z z-score. So first, let's locate negative 1.24. So it's between negative 1 and negative 2, assuming that this is negative 1.24, and we have positive 2.36. So it's between 2 and 3, assuming that this is 2.36. And please do not forget, again, not to write here 2.36 and this negative 1.24. After that, since the word between, we will shade the area between those two z-scores. So after shading, let's find out the probability notation for this one. So what's the probability notation? You write on the left side the smaller value, which is smaller, of course, the negative 1. So we have the probability notation wherein z is greater than negative 1.24 and less than 2.36. So let's first find the area of negative 1.24. Let's locate. First two digit is 1.2. So this is 1.2. And the last digit is 0.04. And then we get the intersection. Therefore, uh, the area of negative 1.24 is 0.3925. And for the area of 2.36, we determine the first two digit, which is 2.3, and the last digit, which is 0.06. And then we get the intersection. Therefore, the area of 2.36 is 0.4909. So the question there is, does it touches the mean or passes through the mean? Of course, yes. Therefore, so these are the areas now. Therefore, what will we do? Or what shall we do? We will add, na? Since it passes through the mean. So let's add the areas of both z-scores. Therefore, our answer is 0.8834 or 88.34%. And we can say that the probability wherein z is greater than negative 1.24 but less than 2.36 is 88.34%. So next, let's make it quick. How about this? Between z equals positive 1.24. So let's locate positive 1.24, assuming that this is 1.24 and we have 2.36. It's between 2 and 3, but closer to 2, right? So assuming that this is 2.3, let's fix it. Assuming that this is 2.3, just write the values of 1.4 and 2.3 below na, so that I know that that is 2.36 and 1.24. And then after that, we locate we find the area on the z table, which we did already. And the areas are 0.3925 and 0.4909. Of course, for the probability notation, this is a probability notation. Just determine which is smaller, 1.24 or 2.36. It's 1.24. That's why you will write it here. And 2.36, you will write it here. So the question is, does it touches the mean? Of course not. Therefore, you will add or subtract. Answer is subtract. Subtract the larger, which is 0.4909, to smaller one. Therefore, the answer is, okay, this is subtraction. So, this is subtraction. Take note. That is subtraction. So, we subtract 0.4909 to 0.3925, and the answer is still 0.0934, and that is equivalent to 9.84%. Thus, we can say that probability wherein the z-score is less than 1.24 but greater than, or the z-score greater than 1.24 but less than 2.36 is 9.84%. So thank you guys for listening. I hope you learned something. And please do not forget to answer the assignment that I gave you regarding probability notation. That is 5 items, and that will be checked on Friday. I will get or collect those. Thank you.